Today we're going to learn how to solve real-world problems using systems of equations. So let's look at our first problem. In this problem it says Kristin spent $131 on shirts. Fancy shirts cost $28 and plain shirts cost $15. If she bought a total of 7 shirts, how many of each kind did she buy? So the first step for this is to make two equations, because to solve a system, you have to have two different equations that can be used. So if I know that she spent $131 on shirts, and I need to know how many of each kind she bought, what I first know is that she bought a total of 7 shirts. I know that some of them are fancy and some of them are plain, and I don't know how many were fancy and how many are plain. But what I do know is that however many fancy shirts she bought, plus however many plain shirts she bought, gives us a total of 7 shirts, because she bought a total of 7 shirts. The other information I know is that she spent a total of $131. She paid $28 for each fancy shirt, and she paid $15 for each plain shirt. So if I know that she spent $28 for each fancy shirt, that's 28 times however many fancy shirts she purchased. She also spent $15 for each plain shirt, so we add 15 times however many plain shirts she purchased. And I know that if I add these two together, I get a total spent amount of money of $131. So now, once I have created my two equations, I have to choose a method for solving the equation. So when we say choose a method, we're talking about either graphing, substitution, or elimination. Well, when I look at these two equations, it looks like it would be very easy for me to get in this first equation to get either f or p by itself. So I think I'm going to use the substitution method of solving. So to change this so that I can use a substitution, I'm going to get f by itself. So my equation was f plus p equals 7. Well, I want to get f by itself, or I could get p by itself. It doesn't matter. But if I get f by itself, I'm going to subtract p from both sides. So these would cancel and leave me with f equals. And I can write 7 minus p, or negative p plus 7. So now if I know, so I changed my first equation so that f was by itself. I know that f is equal to 7 minus p. So I am going to substitute that in for f in my other equation. So my other equation says 28f plus 15p equals 131. I'm going to plug in 7 for f, or 7 minus p for f, I'm sorry. So instead of 28 times f, I'm going to do 28 times 7 minus p, because that's what I know that f equals. And then I'm going to finish writing the equation, so plus 15p equals 131. So I'll do 28 times 7, and I get 196. Then 28 times negative p, that's a negative 1p, so I'm going to write negative 28p plus 15p equals 131. And then I'm going to combine like terms. So on this side of my equation, I have negative 28p plus 15p. And when I do negative 28 plus positive 15, I get negative 13. So I haven't done anything with my 196, so I'm just going to rewrite 196. Because negative 28p plus positive 15p was negative 13p, I'm writing minus 13p. And all of this still equals 131. So now I'm going to subtract 196 from both sides. When I subtract 196 from this side, it's going to cancel and leave me with negative 13p. When I subtract 196 from 131, I get negative 65. Now to get p by itself, I'm going to divide by negative 13 on both sides. So that will cancel these negative 13s and leave me with p. Negative 65 divided by negative 13 gives me positive 5. That means that there are 5 plain shirts that were purchased. Now, I still need to find out how many fancy shirts were purchased. So if I go back to my equation that I wrote up here, which was F equals 7 minus P, to find out how many fancy shirts, I'm going to plug in 5 for P. So 7 minus 5, and that means there were 2 fancy shirts. So I always need to make sure that I go back and that I have answered the question. And this question asks, how many of each kind did she buy? So we are going to say she bought 5 plain shirts and 2 fancy shirts. All right, let's look at another example. In this example, there are 13 animals in the barn. Some are chickens and some are pigs. So if I stop right there, I don't know how many are chickens and how many are pigs, but I know that if I add the number of chickens to the number of pigs, I'm going to get 13 because there are 13 animals. There are 40 legs in all. How many of each animal are there? Well, we have to think about what we know about a chicken. A chicken has 2 legs. So for a chicken, we're doing 2 legs times however many chickens we have, plus, and then for pigs, our pigs have 4 legs. So we're going to do 4 legs times each pig that we have. And then we know that there are a total of 40 legs. So this gives us a total of 40. Now that we have our 2 equations, we're going to come up with a method of solving. A lot of times, substitution is going to be the best method because you have variables that have coefficients of 1. So in this case, I'm going to take my first equation, which is C plus P equals 13, and I'm going to get C by itself. So I'll subtract P from both sides. These are going to cancel and leave me with C equals, and I can write 13 minus P or negative P plus 13 because they're the same thing. So now since I'm using the substitution method and I've gotten one of my variables by itself from my first equation, I'm now going to plug in 13 minus P for C in this equation. So this second equation was 2C plus 4P equals 40. And instead of C, I'm going to plug in 13 minus P. So this is going to be 2 times 13 minus P. And then I write the rest of the equation, plus 4P equals 40. I'm going to distribute my 2. 2 times 13 is 26. 2 times negative P is negative 2P. And then the rest of my equation is plus 4P equals 40. I'm going to combine my like terms, negative 2P plus positive 4P, and that's positive 2P. So I have 26 plus 2P equals 40. Now I need to get P by itself, so I'm going to subtract 26 from both sides. So when I subtract 26 over here, this is going to cancel and leave me with 2P. When I do 40 minus 26, I get 14. Now I need to get P by itself by dividing by 2 on both sides. So when I divide by 2, those are going to cancel and leave me with P equals. On this side, when I do 14 divided by 2, I get 7. So that means I have 7P, or 7 pigs. Now I'm going to plug that into the equation that I wrote over here, which was C equals 13 minus P, so I can figure out how many chickens I have. So I'm going to plug in 7 for P, so this will be 13 minus 7. And when I do 13 minus 7, I get 6. So finally, I just need to answer my question. And my question asks, how many of each animal are there? So there are 7 pigs and 6 chickens. All right, for the next one, it says a farmhouse shelters 10 animals. Some are pigs and some are ducks. So again, we can stop right there, and we don't know how many of each, but we know that when we add the number of pigs plus the number of ducks, we get 10. Altogether, there are 36 legs. Well, we're going to think about what we did before. We know a pig has 4 legs, so there's 4 legs times each pig. Plus a duck has 2 legs, so there's 2 legs times each duck. And that gives us a total of 36 legs. Now, again, when I look at this system, it looks like Substitution would be the best method for solving. So I'm going to take this equation, P plus D equals 10, and I'm going to get P by itself. So I'm going to subtract D from both sides. Those are going to cancel and leave me with P equals 10 minus D, or negative D plus 10, because it's the same thing. So because I'm using the substitution method, I'm going to take 10 minus D, and I'm going to plug in for P in this second equation. So my second equation says 4P plus 2D equals 36. And instead of P, I'm plugging in 10 minus D. So 4 times 10 minus D plus 2D equals 36. Now I distribute my 4. 4 times 10 is 40. 4 times negative 1D is negative 4D, so minus 4D. Then plus 2D equals 36. Now I combine my like terms. 40 doesn't have a like term, so I'm going to rewrite it. Negative 4D plus positive 2D equals negative 2D, so I'll write minus 2D. And all of this equals 36. Now I need to get D by itself, so I need to get rid of 40. So to get rid of 40, I'm going to subtract 40 from both sides, because this is a positive 40, and 40 minus 40 gives me 0. So those will cancel, and I'm left with negative 2D on that side. On this side, I have to do the same thing, so 36 minus 40, and that's going to give me negative 4. Now I'm going to get D by itself by dividing by negative 2 on both sides, so that will cancel this and leave me with D equals. And when I do negative 4 divided by negative 2, I get positive 2. So that means that there are 2 ducks, and now I need to figure out how many pigs there are. So I'm going to use this equation that I wrote, which was P equals 10 minus D. So I'm going to plug in 2 for D, so 10 minus 2, and that means P equals 8. So I answer the question. There are 2 ducks and 8 pigs on the farm. For this problem, a class of 195 students went on a field trip. They took 7 vehicles, some are cars and some are buses. So if I stop right there, I don't know how many of each I have, but I know I have cars and I have buses. And that altogether, that gives me 7 total vehicles. So I can write an equation from that where cars plus buses equals 7 total vehicles. Then it says, find the number of cars and the number of buses they took if each car holds 5 students and each bus holds 45 students. So if each car holds 5 students, then a car is going to have 5 times however many cars. My buses are going to have 45 students times however many buses we have. And when I add up the number of students in the cars and the number of students in the buses, I know that there were 195 total students. So this equals 195. So now I have my system of equations. I'm going to choose a method to solve. Again, it looks like, because I have coefficients of 1, it looks like substitution is going to be the best method. So I'm going to take C plus B equals 7, and I'm going to get C by itself by subtracting B from both sides. Those will cancel and leave me with C equals 7 minus B, or negative B plus 7. So now that I have C by itself, I'm going to take 7 minus B, and I'm going to plug it in for C in my second equation. So my second equation was 5C plus 45B equals 195. Instead of C, I'm going to write 7 minus B, so this is 5 times C, or 5 times 7 minus B, plus 45B equals 195. Now I'm going to distribute my 5. 5 times 7 is 35. 5 times negative 1B is negative 5B. And then I still have plus 45B equals 195. So now I need to combine my like terms. On this side, I have negative 5B plus positive 45B. So I can't do anything with 35. I'm just going to rewrite it. Negative 5B plus positive 45B gives me positive 40B. So I'll write plus 40B. and this equals 195. Now I'm just going to solve my equation, so I'm going to subtract 35 from both sides, which will get rid of this 35 and leave me with positive 40b. On this side, I have to also subtract 35, so when I do 195 minus 35, I get 160. Now I need to divide by 40 on both sides. So when I divide by 40, that's going to cancel this out, and I need to divide by 40 on this side as well. 160 divided by 40 gives me 4. That means that there are 4 buses. So to figure out how many cars there are, I'm going to take this equation that I wrote, which was cars equals 7 minus buses, and I'm going to plug in 4 for B. So 7 minus 4, which means there are 3 cars. So finally, I answer the question. The question asks how many of each are there. There are 4 buses and 3 cars. All right, for this one, it says Brenda's school is selling tickets to a spring musical. On the first day of ticket sales, the school sold 3 senior citizen tickets and 9 child tickets for a total of $75. If I stop right there, I know that if I'm selling 3 senior citizen tickets and 9 child tickets and I get a total of $75, then it's 3 times whatever the senior citizen ticket cost, plus 9 times whatever the child tickets cost, and it gives me $75. Then the next day, the school took in $67 by selling 8 senior citizen tickets and 5 child tickets. So on this day, they sold 8 times the senior citizen tickets plus 5 times the child tickets, and we get $67. So these are my 2 equations. This is my system of equations. And if I look at this, I notice that I can't really use substitution here because none of my variables have a coefficient of 1. But I also might have a hard time using elimination because I don't have any variables that are opposites. So in this equation, my coefficient of S is 3 and this one is 8. In this one, my coefficient of C is 9 and this one is 5. Those aren't opposites, so I can't add the equations together. They're also not the same number, so I can't subtract the equations. So instead, what I can do, I might want to use elimination still. What I could do is I can multiply both of these equations by a number so that I do end up with opposites. So let's say I want to get my S's to have the same coefficient. Well, if I think about 3 and 8, I know that their first multiple that they have in common is 24. So to get 24, I would have to do 8 times 3. And to get 24 here, I would have to do 3 times 8. So I'm going to multiply both of these equations. So in this case, I'm multiplying this whole equation by 8. So I would have to distribute that 8. 8 times 3s is 24s. 8 times 9c is positive 72c. And then 8 times 75 is 600. So this equals 600. Now I'm going to do the same thing over here with my 3. I'm going to distribute 3 to everything in this equation. 3 times 8s is 24s. 3 times 5c is positive 15c. And 3 times 67 is 201. Now if I look at my equations, they're still equivalent, but I have made it so that I can use the elimination method here. Because my S values have the same coefficient, I can subtract my second equation from my first equation and then solve. So if I subtract these equations, 24s minus 24s is going to cancel out. 72c minus 15c is going to give me 57c. And 600 minus 201 is going to give me 399. So I'm using the elimination method, and I've created two equations that have the same coefficient, and then I have subtracted those equations from each other, and I'm left with the equation 57C equals 399. Now to get C by itself, I just have to divide by 57 on both sides. That means these will cancel and leave me with C equals, and if I do 399 divided by 57, I get 7. That means that the price of a child's ticket is $7. Now I still need to find the price of the senior citizen ticket. So to do that, I'm going to plug in the price of a child's ticket, which is 7, into one of these equations, and it doesn't matter which one. So if I go with the first equation, and I can use the one that I wrote originally, or I could use this one over here. It actually won't matter. I should still get the same answer. So if I plug it into the first equation we wrote, which is 3s plus 9c equals 75, I'm going to do 3s plus 9 times c, but c is 7, equals 75. So 3s plus 9 times 7 gives me 63, and all of this equals 75. I'm going to subtract 63 from both sides. So that will cancel 63 over here and leave me with 3s. 75 minus 63 leaves me with 12 on this side. And now I need to divide by 3 on both sides to get s by itself. So that will get rid of this 3 and leave me with s. And 12 divided by 3 is 4. So that means the cost of a senior citizen ticket is $4. So a senior ticket costs $4, and a child's ticket costs $7.